Consider that you are chilling in your room when your father comes and says,
When you leave your room, turn off the lights.
and your reaction was like, now, you may have paid attention to the instruction or not. It's a 50-50 chance. So, your father decides to check. But before the door is opened, what is the state of light? It is obvious, ain't it? It's either on or off.
But wait, because according to the rules of quantum mechanics, before the door is opened, the light is both off and on.
So, it kinda looks like this.
Sounds pretty crazy, right?
This phenomena is called superposition. Now, let us understand this phenomena in a unique way. Who is Superman? Well, Superman is not an ordinary man, but has the strength of several men combined. Same way, superposition is no ordinary position like me sitting here or you sitting in your home, but it is a combination of many positions. How does that work out? Let's consider like this. Consider a hydrogen atom with an electron revolving around its nucleus. Now, an electron is a very small or a quantum particles and it shows superposition. Now, due to superposition, it will not be here or here but all throughout at the same time. This is because on this quantum level, particles behave as both particles as well as waves. That may seem weird because you see waves of water and particles of rock and you can't mix them both. But experiments have proved this theory right. Now, like in a wave, particles can exist in multiple positions at the same time. In the same way, the electron of the hydrogen atom is present all throughout the orbital at the same time, with more chance of being somewhere while less chance of being somewhere else. But once measured, it occupies a certain position. So before observation, it looks like this, while after observation, it looks like this. Now, if you recall the analogy I narrated in the beginning, you can see that how the tube light was actually a simpler example of superposition being both on and off at the same time before actually being observed. Now, the thing to notice is that superposition can only be shown by quantum or those very small particles like electrons. Because, as we saw earlier, a particle superposition depends upon the wavelength, which is actually inversely proportional to its momentum, which is basically mass times velocity. So, in short, if mass will increase, the wavelength will decrease. Hence, everyday objects have such massive mass that their wavelength or superposition is not observable at all.